I'm a full stack developer. I asked Claude to design a production database for a notification system handling millions of users. It gave me 6 tables, partitioning, partial indexes, seriously impressive. But as a developer, I spotted 3 things that would hurt you in production. Let me walk you through it. Every app needs notifications, millions of rows, fast queries. Let's see if Claude built a Ferrari or a go-kart. Here's my prompt, typing it live right now. Okay, Claude gave me 6 tables. Let me walk through this as a developer. First, table partitioning. This is advanced PostgreSQL. Claude suggested partitioning the notifications table by month. When old data ages out, you just drop an entire partition instant. No slow deletes, no locking. This is exactly what a senior developer would do. Claude nailed this. Second, partial indexes. This is one of PostgreSQL's most underused features. Claude suggested indexing only unread notifications. At a billion rows where 99% are read, that index is 100 times smaller than a full index, fits in memory, stays fast. Most developers don't even know this exists. Claude knew it. Third, separate delivery tracking table. Correct. Writing delivery status updates to a separate table prevents dead tuple bloat on your main notifications table. Smart separation of concerns. Fourth, pre-computed aggregates. Brilliant. Instead of running a count query on billions of rows every page load, Claude created a separate counter table, single row lookup for your unread badge count. This is production thinking. So far, Ferrari. Now let me show you where it becomes a go-kart. Issue 1. JSONB preferences in the users table. Claude stored notification preferences as JSONB directly in the users table. For small apps, fine. But at scale, when you need to query all users who opted out of email, you're doing a JSONB scan across your entire users table. At millions of users, painful. I would normalize this into a separate preferences table with proper indexed rows. Issue 2, missing rate limiting. Claude gave me 6 tables. Not one of them handles rate limiting. As a senior developer, my immediate question is, what stops a bug from sending 1,000 notifications to the same user in 1 minute? You need a rate limit table tracking user type, time window, and count. Missing this in production means one bad deployment floods your users with spam. I have seen this happen. Issue 3, no notification grouping. Claude completely missed batching. Real world. You don't show 47 separate liked your post notifications. You show John and 46 others liked your post. That requires a notification grouped table. Claude thought like a database architect, but not like a product developer. So, honest verdict, Claude got 80% of this right. And honestly, that 80% is impressive. Partitioning, partial indexes, aggregate counters. This is senior level thinking that many developers miss, but that 20%, rate limiting, preference normalization, notification grouping, that's real world experience. Things you only know from systems that actually broke in production. This is exactly what AI does in 2026. It gives you a brilliant starting point in 30 seconds. Your job as a developer is to take that 80% and apply the 20% that only experience teaches you. AI doesn't replace developer experience, it amplifies it. Will AI replace developers? After this test, no. But it will replace developers who refuse to work with it. The developer who uses Claude as a starting point, reviews critically, applies real experience, and ships faster, that developer just became worth 3 developers. Subscribe for real developer AI tests every week. Honest results, no hype. See you in the next one.